allow me to become a bit more sophisticated. Now look at this nasty relationship between x and y. Clearly, I will not be able to solve for y because y is embedded in the input of a transcendental function, but it's also involved in terms involving algebraic functions. So mathematically speaking, I can't isolate y in terms of x. So I guess to find this, I cannot differentiate explicitly. I must differentiate implicitly. So treating y as a function x and differentiating implicitly with respect to x. Here's what I get term by term. Power rule, no tricks. Power rule with maybe one trick. I'm differentiating with respect to x. And so I think since y is some unknown function in x, the chain rule says multiply by the derivative with respect to x of whatever the innermost function was. Now, to differentiate sign of anything, I simply get positive cosine of that thing. However, notice that the chain rule says I've got to multiply by the derivative of what I was taking the sign of. That would be a product rule and chain rule application. So here I go. Product rule first. Here's the first. Sorry about that. Times the second. Plus the second times the first. Now, differentiating the right-hand side is nothing more than a quotient rule application, but I don't know if I have enough room. Let me try it. Downstairs times the upstairs. Minus upstairs times the downstairs. All over downstairs squared. Okay, everyone. I think that's the only tricky thing I need to do here. I differentiate in place respect to x, but now it is literally a math D game, or shall I say 9th grade algebra game. Because technically speaking, I'm trying to solve for dy dx. And if you notice dy dx everywhere you see it, it's always being raised to the first power. So if you squint your eyes, treat x and y as mere constants, dy dx is exposed in this equation in a linear fashion. This is just a linear equation. So to isolate dy dx should be 100% absolute piece of cake. Well, maybe there's a tad bit of work to do first. Let's see. Number one, I don't like the fact that I've got fractions. I'll get rid of it. I'll multiply both sides by y squared. And do you mind if I simultaneously distribute this multiplication over the addition so I can see which terms involve dy dx? So in both multiplying both sides by y squared and distributing this multiplication over that addition, here's what I got. I'm almost there. Looks to be like this term here, as well as this one, as well as this one, involve dy dx. So how about if I bring all those terms to the left-hand side, all the remaining 3 terms not circled in blue, not having a factor dy dx, to the right-hand side. So bring all 3 of these, circled in blue to the left-hand side, can I also just simultaneously factor out a dy dx? I think of this. Now that I see dy dx only once, piece, okay, to isolate, I'll merely divide both sides, but what's being multiplied to it? Boy, I just love these test-worthy questions.